Today in this video we are going to discuss the integration by partial fraction. So where we use this method when the integrand is given in the form of px upon qx, where px and qx are two functions or algebraic expressions, where the degree of px must be less than the degree of qx. That is, the highest power in the numerator, highest power of variable in the numerator must be less than the highest power of variable in the denominator. Then only we may apply the method integration by partial fraction. So what do we do in this? When qx, that is the expression in the denominator, is given as the product of a number of binomials or quadratic trinomial, then we break this one fraction into a number of fractions such that each fraction has only one binomial in the denominator or a quadratic trinomial. That is called partial fraction. So we break this one fraction in number of partial fractions. And what is the technique? So the algorithm is, if the integrand px upon qx, and qx is given as x plus minus a, means there may be plus x plus something or x minus something, into x plus minus b. Only 2 or 3 or more than 3 linear binomials are given in the denominator, then we assume this expression as a upon x plus minus a plus b upon x plus minus b. And if the integrand is given as px upon x plus minus a into x plus minus b whole square, then we assume this expression as a upon the first linear binomial plus b upon the linear binomial of this whole square, that is only x plus minus b, and then plus c upon its whole square, x plus minus b whole square. And if suppose there is cube, then we have to write down one more term, d upon x plus b whole raised to the power 3, or so on. Third case, if the integrand is given as px upon x plus minus a into x square plus bx plus c, that is px upon x plus minus a into x square plus bx plus c, that is, if the denominator of the integrand is given as the product of a linear binomial and a quadratic trinomial, or it may be factorized in the form of the product of a linear binomial and a quadratic trinomial, because sometimes it is not given in the form of in the factorized form. So if it can be factorized, then first we need to factorize the expression, then we apply any one of these cases. So this is the third case when the denominator can be factorized or already given in the sum in the same form. Then we assume it as a upon first linear binomial x plus a or minus a, whatever it is, plus, and in the numerator of the quadratic trinomial we write bx plus c upon the quadratic trinomial x square plus bx plus c. So there are three forms, and if suppose there are three brackets in the denominator here, in the first case the same form is applied, then we will write a upon this, b upon this, and plus c upon the third bracket, the third linear expression. And as I told, in this, if there is cube, there will be one more term, and if there is raised to the power 4, there will be two more terms. And in the third case, there is only one binomial and other is a quadratic trinomial, then we use this assumption. So this is the algorithm to. Now let us take an example. Integral x plus 2 upon x plus 1 into x minus 2 dx, and so clearly this is an algebraic expression, and the degree of numerator is 1 and the degree of denominator is 2, because if we multiply both these binomials, the highest power of x will be 2. So the method of partial fraction may be applied. So first we have to assume, because this is the case where px, that is some expression, or it may be constant, sometimes there may be 1 upon x plus 1 x minus 2 in the same way, in that case 2 we have to assume in the same way. So here px is x plus 2 and in the denominator there are two linear binomial, that's why we are using this assumption. Let x plus 2 upon x plus 1 into x minus 2 is equal to a upon x plus 1 plus b upon x minus 2. Let it be equation number 1. Then we take LCM, x plus 1 into x minus 2, dividing LCM by this, x plus 1 will be cancelled and we are left with x minus 2, that will multiply a. So a x minus 2 plus b, and here will be x plus 1. So we have taken LCM. Then since their denominators are identical, their numerator must also be identical. So comparing these two fractions, we have to compare their numerators only, because denominators are equal. So x plus 2 must be equal to a x minus 2 plus b x plus 1. Then we substitute a value for x such that either of these two expressions is 0. So suppose if we take x is equal to 2, then x minus 2 will be 0, and if we take x is equal to minus 1, then x plus 1 will be 0. So let us take x is equal to minus 1 first. Substitute x is equal to minus 1 in the whole equation. So we get on the left hand side minus 1 plus 2 is equal to a into minus 1 minus 2, and here minus 1 plus 1 will be 0, so this term becomes 0. So we get minus 1 plus 2 is plus 1 is equal to minus 1 minus 2 is minus 3, so minus 3a, and a is equal to minus 1 upon 3. So in this way we find the value of a. Next we have to substitute x is equal to 2 now. In this we get on the left hand side 2 plus 2, 4 is equal to, on the right hand side 2 minus 2 becomes 0, so this term becomes 0 plus, and here we substitute x is equal to 2, then we get 2 plus 1 3, so 3b plus 3b, or b is equal to 4 upon 3. Then we substitute these obtained value of a and b from here in equation number 1. So putting the values of a and b in equation 1, we get x plus 2 upon x plus 1 into x minus 2 is equal to a upon x plus 1, and a is equal to minus 1 upon 3. So substituting a is equal to minus 1 upon 3, we get minus 1 upon 3 x plus 1. And b is 4 upon 3, so substituting the value of b here, we get 4 upon 3 x minus 2. Now since this is positive term, so we better write it first, 4 upon 3 x minus 2, then minus 1 upon 3 x plus 1, and let it be equation number 2. So we come to our integration. We need to find out integral x plus 2 upon x plus 1 into x minus 2 dx. Now here in this integral we have to write the value of this expression which we obtain in the form of partial fractions. So we get 4 upon 3 x minus 2 minus 1 upon 3 x plus 1 bracket close dx. Now we open up the bracket, then the sign of integration is distributive over any bracket. So if we open this bracket, we get 4 upon 3, because this is constant, should be taken out of this integral sign, and inside we get 1 upon x minus 2 dx minus 1 upon 3 integral 1 upon x plus 1 dx. So simply we have 4 upon 3 integral of 1 upon x minus 2 is log mod x minus 2 minus 1 upon 3 integral of 1 upon x plus 1 is log mod x plus 1 plus c, where c is the constant of integration. So this is the way we integrate an expression of the form px upon x plus a into x plus b. Now the second example we have taken is integral x plus 3 upon x plus 1 into x plus 2 whole square. Now here this is the case 2 where there is a square or a higher power of a linear binomial in the denominator. Then there is a little difference between the first form and this one. So in that form, what we have to do, px upon x plus a into x plus b whole square, and I told for this linear binomial we have only, we assume a upon x plus a simply, and for the next one we assume first b upon the linear form of this quadratic expression, that is x plus b, x plus minus b, and then plus c upon its whole square. And if the power is 3, we need to take one more term d upon x plus minus b whole cube. So here is the case. So we have to assume x plus 3 upon x plus 1 into x plus 2 whole square is equal to a upon x plus 1 plus b upon x plus 2 plus c upon x plus 2 whole square. Then the next steps are the same as we have discussed in the first example. We have to take the LCM of these three. Then whatever we get in the numerator, we have to equate to x plus 3, the numerator on the left hand side, and then substituting the different values of x one by one, we have to find out the possible values of x. But Now one question must arise in your mind, that we have written x is equal to minus 1, then two brackets, two terms become 0, this one and we get the value of a from this, and when we substituted x is equal to minus 2, two terms become 0 and the value of c we have calculated here. But there is no third kind of expression which can be 0 in such a way that the term having a and c becomes 0 and only the term having b remains non-zero. So in that situation, what we have to do, we have to assume any easy value like x is equal to 0, and putting here in this we get 0 plus 3 is equal to 3 is equal to 0 plus 2, 2 square is 4, so we get 4a, and here 0 plus 1, 1, 0 plus 2, 2, 1 into 2, 2, so plus 2b, and here was 0 plus 1, 1, so only c. Then we substitute the value of a and c here in this equation. So 3 is equal to a is equal to 2. So 2 4s are 8 plus 2b as it is, and the value of c is minus 1, so minus 1. So 3 is equal to 8 minus 1 is 7 plus 2b. So transposing 7 to this side, it becomes 3 minus 7 or minus 4, that is 2b, and this way b is equal to minus 2. So this way we find the values of a, b and c, and now we have to substitute these values in this equation. Now we get x plus 3 upon x plus 1 x plus 2 whole square is equal to a upon, and a we have calculated as 2, so 2 upon x plus 1 plus b upon x plus 2, so the value of b is minus 2, so we get minus 2 upon x plus 2, then plus c upon x plus 2 whole square, and c is minus 1, so plus minus minus 1 upon x plus 2 whole square. So now this integral x plus 3 upon x plus 1 into x plus 2 whole square dx may be written as integral 2 upon x plus 1 dx minus integral 2 upon x plus 2 dx minus integral 1 upon x plus 2 whole square dx. So here 2 may be taken out, we get inside only 1 upon x plus 1 dx, and minus again 2 here, we get 1 upon x plus 2 dx, and minus integral, and we may write this as x plus 2 raised to the power minus 2 dx. Now integrating we get 2 log mod x plus 1 minus 2 log mod x plus 2 minus the integral of x plus 2 raised to the power minus 2 is x plus 2 raised to the power minus 1 upon minus 1 plus c. So simplifying we get 2 may be taken common out of these two, so we get log mod x plus 1 minus log mod x plus 2, and here minus into minus plus, and the power is minus 1, so it may be written as 1 upon x plus 2 plus c. Further we may also write log x plus 1 minus log x plus 2 as log x plus 1 upon x plus 2, because log m minus log n is equal to log m upon n. So log mod x plus 1 upon x plus 2 plus 1 upon x plus 2 plus c. Now the next example is integral 1 upon x minus 1 x square plus 2x plus 3. That is the third form of partial fraction, where in the denominator there is one linear binomial and other is quadratic trinomial. Then we first try to factorize. We have to observe this quadratic expression, whether could it be factorized or not. If it could be factorized, then we must factorize it in the form of product of two linear binomials. And if may not be factorized, then we have to use the third form of partial fraction. So here what we have to assume, let x minus 1 x square plus 2x plus 3 is equal to a upon x minus 1. And as I have told in the beginning that in the numerator of the quadratic expression we have to take bx plus c upon x square plus 2x plus 3. So let it be equation number 1. Then we have to take LCM x minus 1 x square plus 2x plus 3. So we get in the numerator a into x square plus 2x plus 3 plus bx plus c into x minus 1. Now, since these two fractions are equal, having identical denominators, so their numerators must also be same. So we have to compare the numerators. 1 is equal to a x square plus 2x plus 3 plus bx plus c x minus 1. Now let x is equal to 1. We get on the left hand side 1 because this is constant, and here in the question we write a. 1 square is 1, 1 into 2 is 2, and 3 as it is. And here, because of this binomial, we substitute 1 here, we get 0. 1 minus 1, 0. So the whole term becomes 0. So we get only 1 is equal to 6a, or a is equal to 1 upon 6. Then we substitute x is equal to 0. X is equal to 0. Then we get 1 on the left hand side as it is, and here if we substitute x is equal to 0, we get 0 plus 0 plus 3. So simply 3a plus here b into 0, 0 plus c, only c is left, and here 0 minus 1 is minus 1. So we get 1 is equal to 3a minus c. And since we have calculated a is equal to 1 upon 6, so putting the value of a here, we get 1 is equal to 3 into 1 upon 6 minus c. Transposing c to left hand side and 1 to right hand side, we get c becomes positive on transposition to left hand side, and 3 to the 6 we get half on the right hand side, and transposing 1 to that right hand side we get minus 1. So ultimately c is equal to half minus 1 is minus half. So for the next step, we have to use any basic value of x which makes our calculations easy. So we may take some other value than these two. So we may take minus 1. So putting in this expression, we get 1 on the left hand side as it is, and on the right hand side a minus 1 square is plus 1, and minus 1 into plus 2 is minus 2 plus 3, and here we get minus 1 into b minus b plus c, and here we get minus 1 minus 1. So simplifying, we get 1 is equal to 1 plus 3 4, 4 minus 2 2. So we get 2a plus, because there is minus 1 becomes minus 2, and minus 2 multiplies minus b becomes plus 2b, and minus 2 into c is minus 2c. Now substituting the value of a and c we have already calculated. Here in this expression we may find the value of b. So 1 is equal to 2 into a is 1 upon 6 plus 2b minus 2 into c is minus 1 upon 2. So minus 1 upon 2. Simplifying, we get 2 3s are 6. 1 is equal to 1 upon 3 plus 2b, and 2 cancelled, and minus into minus becomes plus. So minus on right hand side and left hand side can be cancelled directly, because transposing this to that side or this to this side, we get 2 1s cancelled. So we get only 0 is equal to 1 upon 3 plus 2b. So simply 2b is equal to minus 1 upon 3, and b is equal to minus 1 upon 6. Putting these values in equation number 1, we have to proceed now. Now substituting the values of a, b and c obtained here in this expression, we get 1 upon 6 x minus 1 plus minus 1 upon 6x plus minus 1 upon 2 upon x square plus 2x plus 3 on the right hand side, and on the left hand side the same expression. So we have to simplify it a little bit. 1 upon 6 x minus 1 minus, now we take 1 upon 6 common out of it, we get here x plus 3. If we take minus 1 upon 6 out of it, we have to multiply both we have to divide both the terms by minus 1 upon 6, so we get here 1 and here 3. And in denominator we have the same, x square plus 2x plus 3. That's it. Let it be equation number 2. Now our original integral, that is 1 upon x minus 1 x square plus 2x plus 3 dx becomes 1 upon 6 integral 1 upon x minus 1 dx minus 1 upon 6 integral x plus 3 upon x square plus 2x plus 3 dx. So 1 upon 6 integral 1 upon x minus 1 as it is, because it is integrable now. But here we have to do something else, because there is a quadratic expression in the denominator and a linear in the numerator. So in this case we find the differential of the denominator, first 2x plus 2, and taking common whatever we may take, we see what expressions we have in the bracket. So take 2 common, we get x plus 1. So to simplify this, we have to break x plus 3 as x plus 1, that is this expression plus something whatever is required. So x plus 3 we may write x plus 1 plus 2, or if there is some other number, accordingly we have to write. But first we have to express this in terms of x plus 1. So x plus 3 x plus 1 plus 2 divided by x square plus 2x plus 3 dx. So now is equal to 1 upon 6 integral 1 upon x minus 1 dx minus, if we split them up, we get 1 upon 6 integral x plus 1 upon x square plus 2x plus 3 dx, and next minus 1 upon 6 integral 2 upon x square plus 2x plus 3 dx. 1 upon 6 integral 1 upon x minus 1 dx minus, here we better multiply and divide by 2. So we divide outside the integral and multiply inside the integral. We may write it as 1 upon 12 integral 2x plus 1. Why we have done so? To make the expression exactly equal to the differential of the denominator, so that we may assume this as some other variable u, and it becomes du directly, and we get 1 upon u du, which may be integrated easily. And here 2 may be taken out, so we may have 1 upon 3 integral 1 upon, and here this expression may be written as x square plus 2x plus 1 plus 2. What we have to do, we have to make this expression, we have to write this expression in a standard form, so that we may integrate it easily using a particular standard formula. So here we have broken 3 as 1 plus 2, so that x square plus 2x plus 1 becomes x plus 1 whole square. So we may write it as x plus 1 whole square and plus 2 as it is. Plus 2 may be written as under root 2 whole square. Now it's okay. Now 1 upon 6 integral of this is log mod x minus 1 minus 1 upon 12, and as I said, this may be assumed as u, so this becomes du, because the differential of this expression is exactly 2x plus 1, so we get integral 1 upon u du, whose integral is log u, and because u is x square plus 2x plus 3, so finally if we substitute u is equal to this expression, we get x square plus 2x plus 3 here. So 1 upon 12 log x square plus 2x plus 3 and minus 1 upon 3, and here we may use the formula 1 upon x square plus a square, whose integral is 1 upon a tan inverse x upon a. So here a is under root 2, and in place of x there is x plus 1, so 1 upon a, that is 1 upon under root 2 tan inverse x, means x plus 1 upon a, that is under root 2 plus c. So this is the way to integrate an integrand in this form. Now in the next part of the video, I am going to explain some of the important sums quickly.